Hello, calculus, and welcome to the second part of 5.3. This part's going to be on concavity and how our graphs go and a little bit more graphing on this order. So make sure you got your notes ready, you got some graph paper, and we're set. So now when you look at this one, you have graphs in front of you, and all we're talking about is concavity. So when you look here, I have this here is called concave down. If you look at if you put water in it, it would not hold. So it's down. This is concave up. It means it would actually hold water. So when you look here, this is down. This is up. This here is all down. I'm sorry, all up, concave up, because it's always holding water. This here part also is concave up, positive slope, and slows this one. Still concave up. I know the water would technically fall out, but there is no negative side. Okay, when you look at this one, we have a positive slope, 0, negative slope, so they flipped around. When you do that, it's concave down. Again, it's decreasing, decreasing, decreasing. Since it's always decreasing, it's also concave down. I know, nothing too earth-shattering, right? So the test for concavity is your second derivative. And we're going to do second derivatives and find out if it exists and then if it's opening up or down. Works very similar to the first derivative test, except the first derivative just gave us answers. Second derivative actually gives us concavity. Both are very helpful. Okay, I want to know concave up, concave down, and inflection points. That's all we're looking for. Nothing major yet. So here is my original function. So in order to find this, we do the first derivative. So it's just 5x to the fourth minus 30x squared. And we need the second derivative for concavity. So we do the second derivative. So we got 20x cubed minus 180x. I need to know when this is greater than, less than, or equal to 0. So what we do is we take this derivative, we set it equal to 0. So this is your second derivative, set equal to 0. Factored out the 20x, x squared minus plus 3 minus 3. So my 3 points that are important are 0, negative 3, and 3. Okay? These are inflection points is what they are on my graph. So now if I plug these into the original, not the inflection, so this is plugged into the original, I do 0, negative 3 is 567, and f of 3 is negative 567. Okay, these are inflection points. Now I have to find concavity. So what we do is we go to our graph, just like before. So I've got the negative 3, the 0, and the 3. And I got to pick points to check in between. So let's pick negative 4. Let's do, it doesn't really matter, negative 2, 1, 4. Or maybe negative 1. Okay, so what I do is I take this negative 4 and I plug it into this part. So this is negative. That's what this negative means. Negative 4 plus 3 is negative. Negative 4 minus 3 is also negative. So a negative times a negative times a negative is a negative. That means this section is concave down. All right, now I look at negative 2. So I plug in negative 2 up here again. So this is negative, positive, negative. Negative, positive, negative. Multiply that, that's positive. So this section between negative 3 and 0 is concave up. Plug in 1. We have a positive, and a negative. You can hit negative, concave down. Plug in 4. So this would be positive, positive, and positive, making him concave up. All right, we've got our 3 points from right here. Okay, so we're going to graph these and figure out what this graph looks like. So now we're going to graph 0, 0. That's my first one. We have negative 3, 567, which is right here. Then we have positive 3, negative 567, which is right here. Those are my inflection points. It's concave down before this, so this section of the graph has to open down. At the inflection point, it turns to concave up until I hit 0. At 0, it turns to concave down. And then at 3 again, it turns to concave up. And that is all we're looking for. We're not even looking for x-intercepts yet. All right, Your turn. Find the intervals where the function is concave up, down, and the inflection point. All right, pause and give it a shot. So step 1, you should have found the first derivative, which was 4x cubed minus 24x squared plus 36x. Okay, after you found your first derivative, we're not using that right now, correct? So we found your second derivative because we're looking for just concavity. So you have 12x squared minus 48x plus 36. You take this and you set it equal to 0. So everybody's divisible by 12, so we're going to reduce this thing. So you have x squared minus 4x plus 3 equals 0. So this factors into x minus 3, x minus 1. So we know that x equals 3 and x equals 1 are my points of inflection. So now on your graph, we got to pick things in between. So we've got a 1 and a 3. So we need to pick points that will help us out. So let's go with, say, 0, 2, and 4. Okay, when you plug 0 into here, you have a negative times a negative, which gives you a positive. So this is concave up. And then you go over here, you plug in the 2. I plug in a 2 here, it's a negative, and then a positive. So this is a negative. So this is concave down. Plug in 4, positive, positive. So this whole thing is positive. So this is concave up. All right. Now, in order to graph this, we got to actually plug these into our graph. So when we plug in 1, so you're plugging this into your original. So you're finding f of 1, and that is equal to what? 1 minus 8 plus 18. Okay, so this is equal to 11. And then we're going to plug in f of 3. Use the table mode on your calculator. That's what I did. So that's 3 to the 4th minus 8 times 3 cubed plus 18 times 3 squared. And if I did that right, that equals 27. I know I did not ask you to graph this, but just for fun, let's make sure we're doing okay. So here would be our graph. We would go to 1 and we would go up to 11. And then we would go to 3. And that would be up at 27. Those are concavities. So this is concave up. If you also looked, your x, your 0, 0 was your y-intercept. So this guy is concave up, inflection point, concave down, and okay, I drew that wrong. Let's do that again. So first we go here. We have an inflection. Wow, come on. So we go like this. He's going to go concave up to 17. All right, then he's concave down to 3, which is hard because he's going this way. So he's actually going down the other, and then he's going to turn concave up. So he's like a really, really weird, almost flattening out point right here. And then it goes back up. I know you did not have to do that. I was hoping that might just help you understand. Okay, next point. Second derivative test. If it's greater than 0, it's a max. Less than 0, it's a min. Equal to 0, it is either does not exist or it equals 0. It's one of those two. So those are the points that we were looking at last time when we were graphing. Okay, here's an example. So we do our first derivative, correct? And we just did negative 6x squared plus 6x plus 72. All right. Now we got this here. I'm going to set this equal to 0, factor out the 6, and we got 4 and 3. Okay, now this is my first derivative. So these are my maxes and my mins. Somewhere at here is what we have. So when I plug these in, so when I do f of 4, I always like to do it here so you understand what I'm doing. So f of 4 gives me 208, and f of -3, so this is into the originals where you're plugging it, that is equal to a -135. Okay, so I got my 2 points. I know they're max and mins. I know this is an x cubed. I know it's going to end going down. So I know it looks like this. So in my mind, I already know my first one should be my min and my second one should be my max, which is exactly what it looks like, because -3 is -135, 4 is 208. We're doing good so far. My second derivative gives me my point of inflection. So now we're taking this and we're finding the second derivative. So it's -12x plus 6, set that equal to 0, and we get 0.5. All right, so that's my point of inflection. So I'm going to take 0.5, plug it into my original, right? And I get 0.5, 36.5. Okay, now if I want to check for concavity, I would not have plugged these in actually. We would have had 0.5 on my graph. So the things I would have plugged in was 0 and 1. So when you plug in 0 into here, you get 6. So it's positive. So it's concave up. When you plug in 1 up here, you get negative. So this means this is concave down. I would not have used those 2 points. All right, so we've got this. We've got our 3 points to graph. We know what it looks like. These I actually did up here. So now if we were going to graph that thing, let's just make a little one over here, just so we make sure we're understanding. We would have -3 down here, -135. We would have +4 at up here, 208. We would have 0.5, so halfway at about here, which is 36.5. All right, and 0, 0 was our y-intercept. I know that this is concave up at this half, so it looks like this. And then after the 0.5, it's concave down, so it goes to my max and turns, which is exactly what we thought it should look like. All right, I hope you're using decimals when you're getting stuck. Pause and try yours. Okay, step 1, first derivative, 12x squared plus 14x minus 10. Okay, we're going to set that dude equal to 0. So I'm going to divide it by 2. 6x squared plus 7x minus 5. -30, that gives me 7. So 6x squared, that's going to be a positive 10x minus 3x minus 5. Group. Take out a 2x. X plus 5. 3x plus 5. Take out a -1. 3x plus 5. Factors into 3x plus 5. 2x minus 1. So x equals a -5/3. And x equals 1/2. All right, now, personally, I would take these and plug them into my original, f of 1/2, using your table mode on your calculator, f of -5/3. So this is up here, into your original, so you're plugging these in, correct? Okay, so when you get 1/2, you get 5.25, and -5/3 is 25.6. So if we were going to graph this, currently, we would have 8 for my y-intercept from here. I would go to 1/2 and up 5.25 right here. I would go to -5/3 and down 25.6 right here, roughly, right? 25.6 is there, This is 5.25. Okay, so I know where this thing is turning. I just scrapped negative 5/3 backwards. Sorry about that. Negative 5/3 is 25.5, so he's up here. 25.56, 5.25 is there, 8 there. We're doing good. Okay, now we need to know the point of inflection. So to find him, we do my double derivative. So we're taking the double derivative of this guy. So this is going to equal 24x plus 14. Set that equal to 0. You got x equals negative 14 over 24, which reduces to negative 7/12. All right, let's double check our concavity. So negative 7/12 is what we're looking at. So we'll probably plug in 0 there, negative 1 here, plug in 0, and we get a positive 14, 0 here, positive 14. So this guy's concave up. Plug in negative, we get negative 24 plus 10, so it's negative 10. So he's negative, so this guy's concave down, which is exactly what it should be. So now we're going to plug negative 7/12 into my original. So we have to find F, original, negative 7/12. So this is back into my original, find my point. We plug him in and we get 15.4. So now we're going to go to a negative 7/12. Negative 7/12, negative half up to 15.4. So this guy is going to go up, turn, go through, down, turn. Okay, it kind of missed, but that's not too bad. And it looks exactly like we thought it should. Make sure you're posting questions if you have any. Okay, relative extremas. So we're putting everything together here. So f of x is the original. First thing you got to do is find your first derivative, just like before. Set it equal to 0. We get x equals 0 and x equals 2. So these are where my max and mins are going to happen. Okay, so now if we do f of 0, remember your original, you're going to get 50. And when we do f of 2, again into your original is where you're plugging this, and you're going to get 34. Okay, so we got our 2 points. Now we do our double derivative. So we take this guy, second derivative. So we got 40x cubed minus 60x squared. Set it equal to 0. Okay, when we do this, we're in trouble. Because when we plug in 0, that was also, so I have 0 there as an inflection point, or I mean as a max or min, and when I plug in 0, I also get 0, which is a problem because that gives me my turning point and my inflection point at the same time. So there's something weird going on. So it doesn't tell us anything for my second derivative. So because it does not tell anything, we have to go back to my first derivative and plug in 1 on each side, negative 1 and positive 1. So remember when we used to do that? So here's 0. We're plugging in negative 1 and positive 1, first derivative, all right? So we're at first derivative. So when I plug in negative 1, I got a positive 30. That meant he was going up. When I plugged in 1, I got a negative 10. So that meant he was going down, which means 0 is a max, is what we have to do there. So now when we plug in 0, we already got 50. So I go, no, this guy is a max. So let's keep going. Now we got the 0 when we plugged him in. Also, when we factored this guy out, so let's do this over here. You're going to factor out a 20x squared, which gave you 2x minus 3. All right, so the next point we have here, we got 3/2, right? So we've already done 0. Here's 3/2. 0 was unhelpful. We did -1 and 1. So now we're going to check 2 on the other side. So when we plug in 2, we get 80. So it's positive. So this is concave up. All right. It also happens to be the one we just picked, which means 234 is a min. So it happened to be the same problem, which is just fine. So if we went to graph that thing, which we don't necessarily have to do, but it's still not all bad practice. We're going to go to 0, way up here, to 50, okay? And then we're going to go to 2, and that's at 34, and that's a min, and this guy's a max, all right? I think we forgot to plug in 3/2 here. You got to find that. So we're going to do f of 3/2 into your original. When you plug that in, you're going to get 39.9. So we're going to go to 1.5. We're going to go up here. That's my point of inflection. And now we just graph in our graph. And we're good. Okay, let's see how you're doing here. There's a lot to do on this, I know. So don't freak out. Just take them in time, one at a step. Step 1, find your first derivative. You all know how to do that. So that's negative 6x squared plus 6x plus 72. Second step, set it equal to 0. Okay, I'm going to divide everybody by a -6. So you get x squared minus x minus 12 equals 0. Factor that guy out. So you get x minus 4, x plus 3. So x equals 4, x equals -3. Okay, so we know 4 and -3 are our in maxes and mins. -2x cubed, remember what that looks like. So it's going to look like this. We know that. So now we're going to plug in. We got to find our points, correct? So I need to plug into my original, f of 4 and f of -3. So again, you're finding points. So they're going in up here using their table mode. And you get 208 and -135. Okay, so currently on our graph, we're going to go to 4, and we're going to be up here at 208. We're going to go to -3, and we're going to be down here at -135. We're doing good so far. If you look at this here, there's no y-intercept, so the y-intercept is 0, 0. Okay, so we've got that guy. So the next thing we need to know is our point of inflection. So you're not making this hard, right? So you're going to do f double prime of x. So you're doing your derivative of this guy. So you got -12x plus 6. Set that equal to 0. So we're going to subtract the 6, divide by -12, and I got positive 1/2. That's my point of inflection. So again, we're going to plug this into our original using my table mode, and I'm going to get 36.5. So now I'm going to go to 1/2. I'm going to go up to about right here. We'll call that 36.5. We're doing good so far. We want to know concavity. We should already know that because we could technically graph this thing in, right? We know that's a turning point. We know we go for the 0, 0. We know that's a point of inflection, and that's a turning point. But let's check it out just to make sure. So 1/2 is the point we're going to look at. We're going to plug in 0 here, 1 here. When we plug in 0 up here, we get a positive 6. So this is concave up. When we plug in 1, we get a -6. So this is concave down, which is exactly what your graph looks like. And I hope you did a good job. Okay, last but not least, story problems, your favorite, right? Point of diminishing return, the point at which the dollar invested returns less than the previous invested money. So it doesn't mean you're not making money. You're just not making as much as you did the time before. Okay, it's found at the inflection point, which is the second derivative. So all we're going to do here is do first and second derivative. But to do this, we're going to multiply this guy through so we have two separate things to make our life a little easier. So r of x is equal to 600 x squared over 15,000 minus x cubed over 15,000. Okay, I'm going to reduce this, and I'm actually going to put them into decimals. So the first one is 0.04 x squared minus 0.000067 x cubed. That's my first one, or my original. Now I'm going to find my first derivative. So that's going to give me 0.08 minus, take 3 times that, and you get 0.1232 x squared. Okay, the one I care about though is the second derivative. So we're going to add our double prime of x. So this is going to be 0.08 minus 0.0004 of x. We're going to set him equal to 0. Solve for x. So you're going to subtract your 0.08, divide by your negative 0.04. So you got x equals negative 0.08 divided by negative 0.0004. And when you type that in, that equals 200. So at 200, we're going to plug this into the original. So back into r of x. So we're going to do r of 200, your original. So you plug it into your revenue, and you get 11,066.67. Okay, what that means. Oh, I want to do one more thing, just so you understand. We're going to plug this into your first derivative, point of inflection. We're going to plug in the 200. And when you plug 200 into your r prime, so you're taking the 0.08 times 200 minus 0.0002 times 200 squared. That equals 8. That's $8 is what that's talking about. This means, okay, are you listening? When you invest $200,000, because this is actually $100,000, comes from here. If you invest another $1,000, so the next point that you're going to invest at, you will make an additional $8,000. All of this was in thousands. I forgot to write that at the beginning. So it doesn't mean you should keep investing because you are still making very good money. It just means you're not making as much as you were before 200. That's all it is. Still a good return. Hey, good luck and do well on your homework. Post questions if